So hello my dear students and learners. So in the series of data structures and algorithms, in my previous video, I have discussed about the basic concepts of linked list, and we have also gone through various type of linked list. Okay, now today I am going to implement the very first function of a single linked list, which will add a new node at the beginning of the list. Okay, so the added begin function today we are going to define. Now before writing the function, we will define the structure first. In my previous video, although I have declared it, so you know that in a single linked list, each and every node actually containing two parts. Okay, the first part is the data part and the second part is the next part. So first we will declare the structure. So struct is the keyword. So name of the structure is node. The first member will be data and its data type is integer. That means we are going to store integer type of value in the data part of each and every node of the linked list. And the next part is a pointer and the name of the part is next. So struct node start next. And that is the end of the structure. So each and every node is being defined by a structure. The first part is the data part and the second part is the next part. It is a pointer. That's why it has been declared as an asterisk symbol. This is the meaning of a pointer and its type is struct node type. So this pointer actually contains the address of another node of the linked list. So it is pointing to another node. Okay. Now before defining the function, we will declare the function. That means we will mention the prototype of the function. Okay, so what will be the prototype? So first you will have to mention the return type of the function. So suppose you do not want to have any return from the function, so void, then name of the function. This is an user defined function, we are defining it, so any name you can give. So I am giving the name of the function is add at begin. Okay, so this is the name of the function, and suppose it is not accepting any parameter, so we are only declaring it. So we are ending it with a semicolon. We are not defining it, we are just declaring the function. That means we are mentioning the prototype of the function. So whenever why this declaration is required, because we are going to call this function from the main function. So since it is an user defined function, so whenever you will call this function from the main function, it will be unknown to the compiler if you are not defining it before. Okay, so that's why this declaration is very important. Now after declaration of the structure and the prototype of the function, added begin function, we will define the main function. So the main function, suppose the return type is void, that means it will not return anything, and in the main function we are going to declare a pointer. What type of pointer? The node type of pointer. Okay, so struct node star. So it is a node type pointer and the name of the pointer is head. Now in my previous video I have drawn the diagram, and that time I have told you that this head pointer is very important whenever you are working with a linked list. It may be the single linked list or double linked list, because this head pointer will contain the address of the first node of the list. Okay, because whenever you are working with a linked list, okay, in single linked list or double linked list or circular linked list, you have to always start from the beginning of the list. You cannot start randomly from any other node. Okay, so at present we have not created the linked list. Okay, so no first node is there, and if the first node is not there, that means the head is not pointing to anywhere right now. So the content of the head will be null. So this value we are assigning. So in this line, what we have done, we have declared a node pointer. The name of the pointer is head, and where we are assigning the value null to this pointer. That means the content of the head is null. That means head is pointing to the null. That means head is not pointing to anywhere. That means the first node is not there in the list. Okay, so this is the declaration we have done, and from this main function we will call this add at begin function. Okay, so that we are going to define very soon. Okay, so this is the structure part we have declared, this is the prototype we have declared, and this is the main function we have declared. Okay, now we will define the add at begin function. Okay, now before defining this added begin function, we will first draw the figure. Okay, so it will be easier for us to write the code. Now whenever you are going to write add a new node at the beginning of the linked list, single linked list, you may have to face two kind of situation. The situation number one is the linked list where you are going to insert the first node. Suppose the list does not exist, that means no node are there, so the list is empty, so you have to consider the empty list. In the empty list we can also insert a node at the beginning of the list. Similarly, the second case, it may happen that the list is already there, that means list exists, and in this existing list, whatever may be the number of nodes are there, we have to add a new node at the beginning of this existing list. So two kind of situation we have to consider whenever we are going to write this function. First, the empty list, that means no node was there, and the second one is the existing list where at least one node will be there. Okay, so first we will draw the figure. So case number one is empty list. So you can check that in this empty list, that means list does not exist, so no first node is there, so head is actually containing the null value. So this is the empty list. Now the second case that we will also consider is existing list. Existing list means at least one node will be there. So in this list we will consider at least 3 nodes. Okay, so suppose this is the existing list. So 3 nodes are there, node number 1, node number 2 and node number 3. Suppose the address of the node number 1 is 100, address of the second node is 200 and address of the third node is 300. Okay, so head will contain the address of the first node and here it is 100. Okay, now I have already told you in my previous video that this address we are assuming, okay, it can be any other address, okay, and it will be assigned by the compiler only. We cannot predict this address or even we cannot demand any address. So for the sake of understanding, for the time being, we are assuming this kind of addresses. Okay, now we have declared our structure, that is data parts will contain an integer value. So suppose we are assigning some integer value over there. So 7, suppose it is 3 and it is 11. Okay, so each and every node's data parts are containing integer value, and its next part, 100 next part will contain 200 and 200 next node is 300, so its next part will contain 300 and 300 next part is null because it is the last node of the list. You know that last node next part will always contain a null value. Okay, now these nodes are connected like that. So this is the empty list and this is the existing list. So we will check both the situation that whether our function that we are going to write are working on these two situations or in this two linked list or not. Okay, so first we have to write down the header line of the function. So the name of the function is add at begin, its return type is void, so void add at begin. Okay, it was not accepting any parameter. Okay, now first what we have to do, since we are going to add a new node, so we have to create a new node. So before creating this new node, whenever you will create a new node, the malloc function will return the starting address. So first you have to declare a node pointer so that this starting address can be pointed by this new pointer. So first we will declare a node pointer. Okay, so struct node star nw. NW stands for new. So it is a node pointer which can point to any node. Okay, so it will point to the new node that we are going to create. Now we will create the node pointer is ready. Now we will create the new node using the malloc function. So nw is equal to struct node star malloc size of struct node. Okay, so here we have called the malloc function. Look at this malloc function. So malloc function will reserve the memory. Now how many bytes will be allocated? So this is size of operator, size of struct node. Now I have already defined that node, and this node actually containing two different members, so data part and the next part. So data part means it is an integer part, so it will allocate 4 bytes of memory, and the next part it is a pointer, and pointer means what? It is an address, and it is address means it is also an integer value. So integer will also, the pointer part will also take 4 bytes and the integer data part will also take 4 bytes. So 4 plus 4, that is 8 bytes will be required or 8 bytes will be allocated by the malloc function. So this meaning of size of struct node means it is 8. So malloc 8 means malloc will allocate 8 bytes of memory, and after allocating 8 bytes of memory, it will return the base address of this 8 byte to the NW pointer. Now what is this? This is typecasting. I have already discussed these things. Okay, so in my previous video, so you please go through these videos before going to these videos. Okay, so actually the malloc function is returning a void pointer. Now this pointer actually being assigned to what type of pointer? NW. Now NW is what type of pointer? We have already declared this is a struct node type pointer. So although malloc function is returning a void pointer, so first we will convert it to the struct node type pointer, because this address is going to be assigned to a pointer NW which we have declared as a node pointer. So this void pointer which is being returned by the malloc function, first we have to convert by node pointer. Okay, so this is called typecasting. We are casting the type from void to node pointer, and then we are assigning. So after executing this line by the compiler, what will happen? It will create a new node. Okay, so suppose this is the node malloc is creating. Okay, suppose the address of the node is 50. Okay, so since we are considering both this situation, so suppose the new node we have already created, the address is 50. Okay, and this 50 address is being assigned to new pointer. So this 50 is being pointed by NW pointer. So that means the value of NW is 50. That means NW is pointing to this address 50. Okay, so now the node is ready, which is being pointed by NW. Now we have to access both the data part and the next part. Okay, since we are considering both the empty list and existing list, that's why we have mentioned this node in both the cases. But actually only a single node will be created. Now we have to access the data parts. Now in the data part, what we are going to store? An integer value. Now we have to ask the user to enter this integer value so that this value can be assigned to the data part. So now we are printing a statement. Okay, so before printing we have to declare an integer variable. So now we are printing the statement enter a number. Now after executing this line, the user will be able to understand that I have to enter a number. So we have to scan this number. So scanf, we are calling this scanf function. So integer value, that means the format specifier is %d. Now we are scanning this value which is going to be stored in the address of num. Okay, so %num. So the number is ready that we have taken from the user, and this num we are going to assign in the data part. So the data part of which node? That is being pointed by the NW pointer. Okay, so how to access this data part? We have to access this data part as NW arrow data. Okay, so why this arrow operator? Because here you check that NW is a pointed type structure variable, and we are accessing the members. First member is data. So if the structure variable is pointed type, you have to use the arrow operator. Okay, so if you want to go in detail about this structure concept, please go through this my previous two videos, lecture videos in data structures and algorithm learning series, video number 8 and 9. Okay, you will have a clear-cut understanding about that. Okay, so we are accessing the data part of NW. That's why we are writing NW arrow data. What we are going to store? The value that we have just taken from the user. So that is the num. Okay, so this num is going to be stored here. So suppose the number that we have taken from the user is 15. Okay, so we have stored the value 15. Now check for the empty list case. So here, since the list was empty, so the node that we are placing here, that will be the first node, because we are adding at the beginning, as well as since this is the only node that have created so far, so this will be the last node also. So last node means yes, next part will be null. Okay, so you have to store a null here in the case of empty, null. Okay, now in case of existing list, look at that. Here this is the new node that is being pointed by NW, and it will be placed at the first position. So now this will be the first node, and the previous first node will be current second node. the previous second node will be the current third node, and previous third node will be the current fourth node, because we are inserting this node at the beginning, so that will be the first. So previous first will be second, previous second will be third, and previous third will be fourth node, like that. So what you have to do, we have to make a connection between the first node and the second node. How to make this connection? We have to mention the address of the current second node, actually that was the address of the previous first node, in the next part of this newly created node. So if we can mention 100 here, so that means after 50, 100 will be the next node. Okay, so if we mention here 100, then what will happen? It will be assumed that after 50, the next node is 100. That means we can set up a connection between these two. Now how to make this connection? Now which part we want to access? We want to access the next part of which node? NW, that is being pointed by NW. So NW arrow next. So we are accessing the next member as NW arrow next. So here you check. In case of empty list we are assigning null, and check which value was null. The null was the value of head. Okay, so if we write head in place of NW arrow next, if we write head, that means null value will be stored. And if null value will be stored, it is working fine, because in an empty list, after inserting the first node, this will be the first node, as well it will be the last node. So last node next part is containing null, so it is working fine. Now we have to check, will the same syntax also work for the existing list? We are checking. So NW arrow next, that is, this is the part what you have stored 100. Now my dear students, you check that before inserting this node, 100 was the content of head and 100 was the first node, since 100 was the first node. So can we not say that this 100 was being pointed by the head pointer, because head is the pointer, it is containing 100 and it is the address of the first node. So before inserting this node, the content of head was 100. That means head was pointing to the first node, previous first node. Okay, now if we write this statement that NW arrow next is equals to head, that means what is the present value of head? It is 100. So NW arrow next, that means this place it will be 100, that means it will be head, that is 100. So the setup. So this statement actually is working for both the cases, for empty cases as well for existing cases. Now after accessing the both the part, data part and the next part, now we have to change the head node. Why head pointer? Because we have inserted the node at the beginning of the list, and beginning of the list means a new node has been assigned to this first place. Okay, and you know that head content is nothing but the address of the first node. So this is the current first node 50. So you have to change the head content as 50. Okay, what is the address here? 50. So you have to change the content of the head as 50. Okay, so how to change? We have to write head is equals to, what is the content of head? 50, and in both the cases it will be 50. That means 50 will be the first node. Here it will be the first node. Okay, so who is pointing to 50? You check the pointer NW. So we'll write head is equals to NW. That means the NW value, that is 50, will now be assigned to head. 50 will be assigned. So in case of after executing this line, you check that head content is 50 and 50 is the first node and its next part is null. That means it is the last node also, because the list was empty. We have just inserted a single node. So this has become the first node as well as the last node. And in case of existing list, you check current head content is 50. So this is the starting node. Now 50 next part is 100. Go to the 100. 100 next part is 200. So 200 is the next node. Then 200 next part is 300. And 300 is the last node, since its next part is containing null. So after writing this code, we have also checked the figure, and figure is saying that our code is correct. So that is the end of the added begin function. Okay, so it will be advised to my all students and learners that whenever you are writing any code, in case of single linked list or double linked list or circular linked list, please draw the figure, because you do not need to remember anything. You just draw the figure. Figure will tell you that what will be the next line that you have to write. Okay, so my dear students, I hope that you have understood the concept of adding a new node at the beginning of a single linked list. So thanks for watching. Please take care. Have a nice day. Thank you.